So looking at Unit 3, Topic 3, Formative, we're going to say verify. We're going to start off by drawing our line. So we're going to convert the sine of 2 theta to be 2 sine of theta cosine of theta over sine of theta minus, and I'm going to convert this quantity to be cosine squared theta minus sine squared theta over cosine. Now with that done, right, this is actually wrapped in parentheses right here in that quantity. I can also cancel these two because they're within the same fraction, right? Sine divided by sine. So I'm now left with 2 cosine of theta minus, and then parentheses, cosine squared theta minus sine squared theta over cosine. Now I want to make sure I have a common denominator, so I'm going to make sure that this is cosine on the bottom, cosine of theta. So then if I make a cosine on the bottom, I'm going to also put one on the top, so that will make that squared. And now I'm going to have 2 cosine squared theta. Now I'm going to also distribute this negative, so this will now become negative cosine squared theta plus sine squared theta, and then all over cosine of theta. And then I can see right here that both of these are both cosine squareds, but this one has 2 of them. So if we simplify that down, 2 cosine squared thetas minus 1 sine squared theta, that would just leave us with cosine squared theta plus sine squared theta, and then over cosine. And we know cosine squared plus sine squared equals 1, so it's going to be 1 over cosine of theta, which ends up giving us, over here, secant of theta. Number 2. So we have to remember that when we do a squared minus b squared, that ends up giving us a minus b, a plus b. So if I do a to the 4th minus b to the 4th, well, this would be a to the 2nd minus b to the 2nd, and then a squared plus b squared. It works out the same way. So with that in mind, this is going to end up giving us cosine squared x minus sine squared x, and then cosine squared x plus sine squared x. This ends up turning into just 1. So the only thing that we're left with is cosine squared x minus sine squared x, and that can actually be rewritten as cosine 2x, which is the right-hand side. Number 3. This is going to turn into 2 sine of theta, cosine of theta. That is one of the formulas that is going to be given to you tomorrow. So sine of 2 theta. So that's going to be 2 sine cosine. On the right-hand side, this quantity right here, 1 plus tangent squared, is going to end up giving us secant squared theta with a tangent to, or 2 tangent theta. Now what I'm going to do here is I know that secant squared is on the bottom. If I bring that to the top, that actually ends up becoming cosine. So I'm going to say 2 times tangent of theta times cosine squared theta. And then rewrite it in terms of sine and cosine. 2 sine of theta over cosine of theta times cosine squared of theta. So one of those cosines goes away with the one that's on the bottom. And then I'm left with 2 sine cosine, which is the left-hand side. Over here, I'm going to rewrite tangent as sine squared theta over cosine squared theta times sine squared theta. Now this is over 1. They do not cancel because they're both in the numerator. So sine squared times sine squared gives me sine to the 4th of theta over cosine squared theta. Now that looks weird, but we're still going to continue with it. So this is going to be sine squared theta over cosine squared theta minus sine squared theta, and since there's no denominator, that's going to be over 1. So to find a common denominator, I'm going to multiply both sides, or both numerator and denominator, by cosine squared theta. So I'm going to end up getting the following. Sine squared theta minus sine squared theta, cosine squared theta, and then over cosine squared theta. If I take a look, this quantity and this quantity, they both share. So I'm going to factor out a sine squared theta. I'm left with 1 minus cosine squared theta. Remember, that's like the opposite distribution over cosine squared theta. And then I can see right here, this 1 minus cosine squared ends up giving me another sine squared. I'm going to just do some work over here. So this is going to be sine squared theta times sine squared theta over cosine squared theta. And sine squared times sine squared gives me sine to the fourth theta over cosine squared of theta. And that gives me my other side over here. Moving over to number 7, this says simplify. So I'm going to use the sum and difference formulas. The sum and difference formulas for sine goes sine, cosine, cosine, sine. This is given to you on the formula sheet. So this will be 3 pi over 2. This will be x. This will be 3 pi over 2. This will be x. And it's addition because there's an addition sign there. So now we're going to have to remember sine of 3 pi over 2. That would be right at this value. So the y value for this is going to be -1 cosine of x. Cosine is really the x value, so the x value of this is going to be 0, so that's 0 sine of x. And I end up getting negative cosine of x is my value, number 2. Or number 7, I should say. I think I jumped around. Yeah, there's no like number 5 and number 6. All right, number 8, same deal. But this time we're going to do cosine, cosine, sine change, sine, sine. So cosine, cosine, sine, sine, sine. So theta, pi over 2, theta, pi over 2. So cosine of pi over 2, which is going to be right here, the x value is actually going to be 0. So cosine of theta times 0 is just going to be 0, plus sine of theta times, well, 1. So it's going to be sine of theta plus 0, so that's just going to be sine of theta. Evaluate, number 9. Sine of, and then this is where we're going to use the sum and differences to be able to kind of break it into part 2 angles that we're more familiar with. So this is going to be 45 degrees and 60 degrees. You could also do this many other ways. You could do this, let's say you could do 135 minus, minus 30 or something like that. That would work just fine. So we're going to write sine, cosine, cosine, sine. And I'm going to write this as 45, 60, same addition, 45, 60. So it gives me sine of 45, which is going to be root 2 over 2. Cosine of 60 is going to be 1/2, plus cosine of 45 is going to be root 2 over 2. And then sine of 60 is going to be root 3 over 2. So we multiply across whenever we multiply. So it's going to be root 2 over 4 plus root 2 times root 6 is, or root 3 is going to be root 6 over 4. Notice how they have a common denominator, so I'm going to write this as root 2 plus root 6 all over 4. And that is my final answer. Now you can reverse these, and so maybe the root 6 would lead first and then the root 2 would be afterwards, but really it's still all over 4. Number 10. So there are 2 different parts here. So there's the alpha section and there is the beta section. So I'm going to be drawing 2 triangles. So 1 and then 2. So I'm going to be working with the alpha first. So it says cosecant, which is another way of saying sine of alpha, is going to be 12 over 13. Right, I don't like cosecant. I'm just writing for terms of sine. So we'll also notice that sine is positive. Then they also say that cosine of alpha is also positive. So that quadrant is going to be in the first quadrant where both sine and cosine are positive. So we're going to draw our triangle in the first quadrant right here. The y value, because remember sine is y over r, is going to be 12 here. This is going to be 13. And then one of our special right triangles, this is going to lead with 5. So 5, 12, 13. So we're going to say sine of alpha is going to be 12 over 13. We're going to say cosine of alpha is going to be 5 over 13. And those are the things that I need for this problem. Moving on, let's move with beta. So this is really saying cosine of beta is equal to 3 over 5. But it also says tangent is negative because it's less than 0. So where is cosine positive, but tangent is negative? So all students take calc. So the two values where cosine is positive is quadrant 4 and quadrant 1. But tangent is not positive in quadrant 3, so that is where we want to draw our triangle. So we're going to draw that here. Okay, cosine is x over r, so 3 is going to go here, 5 is going to go here, and then the y value is going to be negative 4. So we're going to write this as sine of beta is going to be negative 4 over 5, and cosine of beta is going to be 3 over 5. All right, now finally on to the actual problem itself. Find sine of alpha minus beta. So we're going to do sine, cosine, cosine, sine. Just as what we did before. Same operation, so it's going to be negative. Place in alpha, place in beta, place in alpha, place in beta. Okay, alpha is going to be 12 over 13. Cosine of beta is going to be 3 over 5. Match it up with like the things that we have. So I did that, Minus cosine of alpha, that's that one, so it's going to be 5 over 13. And then sine of beta, which is going to be negative 4 over 5. And then multiply and then add together. I'm going to move this out of the way. So 12 times 3 gives me 36 over 65 minus, and then this is going to be 5 times negative 4, so that's going to be negative 20. So it's really just going to be plus over 65. Add those two together and we get 56 over 65 is my final answer for number 10. Hope you enjoyed this video. I'll see you later.